Alright, so if you've been watching a lot of these videos now, you'll know that I've been talking about this pilot. He's flying up and he's flying down. The x-axis is the seconds, so from time 0 all the way down to time 30. Now, this is the function that his flight path follows. Now, if we want to find the instantaneous rate of change at any time for this pilot, for instance, what is the pilot's rate of change at 18 seconds? Exactly at 18 seconds. What we're really doing is taking a point at 18, drawing a tangent at that point, a line that just touches the function. That should really just kind of just touch the function at 18 seconds, and finding the gradient of that function. That's what's really happening here. So what is the pilot's rate of change at 18 seconds? If f of x is this, then f dash of x is equal to 12x squared minus 400x plus 2500. Now, this is the gradient function. This tells us the gradient at any time. So the time is x, 18 seconds. If I sub in 18 for x, I'll get an answer of negative 812. Negative 812 what? It's a rate meters per second. Now it's going to be negative because he's going downwards at the 18-second mark, and he's going downwards pretty fast, negative 812 meters per second. So that's a very simple example of how you can find the instantaneous rate of change. If you know the original function, derive it, and then put in the time or the moment or whatever it might, the x value in to find the rate of change. Now these questions can take a lot of different forms, but here is a very simple example of how to find the instantaneous rate of change.